Do you want me to do another problem like this? How about this? Let's do this one. Copy. And, yeah. Yeah. Now I have four states. Okay. Let's go to our Excel template. Uh, where are those? Boom, good, poor, bust. Let's copy the formatting of these two. Okay, what are the probabilities of these? 15, 55, 20, and 10. So in each of those states, uh, for stock A, 13, 11, oh, I think I did it wrong the other time. 13, 11, 2, and negative 12. So for stock B, 45, 10, 2, negative 25. Oops. 33, 17, negative 5, negative 9. That's the first question. 25% each in A and C, 50 in B. So 25, 25, 50. Just read them off. 1054 for the mean, whatever that number in variance. Because variance by itself is not an interesting number because units are square of the mean, but standard deviation is 12 and 51%. Yeah. Remember, for the problem gives the returns in each state vertically. All I have to do is transpose them. I made that mistake the previous time, but this time I haven't. Was that clear, or should I do another one? How about you guys? Oh, I am the third. How about you, Kaylee? Was that clear? No, we're gonna do CAPM next. I just wanted to make sure that you guys got these parts. All right, let's do CAPM. Okay, calculating portfolio betas. Okay. Well, I'm not gonna do it separately. Portfolio betas. Let me just write it here. I can if you want to. Uh, Weighted average of individual betas. So let's do these until 17. Okay. You own a stock portfolio, invest 15% in stock Q, 25% in stock R, 40% in stock S, and 20% in stock T. Okay. And these are the betas. What is the portfolio beta? Let me do this. Let me move this. Even though mathematically it's similar, formatting is a little bit different. These are not percent. Okay. And let's see how many I have. QRST. My amounts are 15, 25, 40, and 20. Weights are automatically calculated. Betas are 78, 87, 113. Now, 145. As I said, mathematically it's the same problem, but the tagging is different. So that's the portfolio beta because it's the weighted sum of the weights and the individual betas. Okay, now this is a good problem. You own a portfolio equally invested in a risk-free asset and two stocks. If one of the stocks has a beta of 129 and the total portfolio is equally as risky as the market, what must the beta for the other stock be in your portfolio? Okay, we're gonna do this. Since they're equal, okay, weights are 1/3. This doesn't mean anything. Let's see. Let's call this risk-free. Let's call it asset one, stock one, stock two. Okay. Let's see. One of the stocks, and I'm gonna call that stock two. Remember, what's the beta of a risk-free asset? You guys remember? No, zero. One is the beta of the market portfolio. Okay. And in this case, we're not doing the amount. Doesn't matter too much anyway. Uh, one of the portfolios, I'm gonna call this, yeah, let me tag this differently. All we know is that one of the stocks is at beta of 129. So I'm going to make that stock one. The second one, we don't know, but the objective is to figure that beta such that beta of the portfolio is the same as the market. So what's my desired beta? If I want my portfolio to be as risky as the market, what's my desired beta? One, because that's the beta of the market portfolio, right? So I need to do a goal seek, make that difference zero by changing what I don't know, beta of the second stock. All right. Actually, why did I change that? Let me copy and paste the formulas. Paste the formulas because that's calculated. The only reason I'm using formulas is I'm making sure that they're equal weights. Okay. Because the weights are calculated automatically. Was that clear, guys, or you want me to go over it again? How about you, Kaylee? All right, thank you. So let's see. Edit that. All right, let's do number 13. I don't know why this has become all bold. Equals risk-free rate plus beta times market risk premium. Or let's just go with MRP. All right.